Hello everyone and welcome back. I am Aditya Bansal and we are on air. We are live on YouTube, Twitch, and X. You can see me on any of these platforms. Let me just check. Yep, we are live on all of three of the platforms. I can see chat from Twitch and YouTube, so you can post any comments there. Let's get started. Let me figure out the awesome. Change the screen once again. I think I should be audible now. Yep. And so we are following this study plan, this top 150 questions. We are going sequentially down the line. I have already solved array and string questions. I have solved 2-pointer questions, then sliding window. We are leaving these hard questions for last. We will approach them at the end because they can be a little bit more time consuming. We did solve this longest consecutive sequence last time. I am not sure why this is not being uh, reflected properly in the list, but let's try submitting it once again. As you can see, it is submitted successfully. And now we can see that the question is marked as solved. So one of the doubts that I had last time was with this path compression algorithm in the union and find. And a regular viewer of mine, Solaris, shared a solution. And I was so confused as to why this was not working. Then later, after the stream, I figured out that I was actually not implementing it correctly. I was writing just if the parent is not equals to x, then just update the x and update it with whatever you find and return the x. So this was not working as intended because this is not leading to path compression. We are just finding the result and returning it. We are not actually updating the parent variable itself. Then I corrected it later on to implement the correct solution. And now this works as path compression, and we are updating parent x with whatever we find. So now our path compression algorithm is correctly implemented and it works as intended. We already have another solution above. So let's move on to the questions that we are focusing on solving today. We have the next topic, intervals. I'm not sure what that means, but we have 4 questions in this list. They are summary ranges, merge intervals, insert interval, and minimum number of arrows to burst balloons. The first question is easy, so let's get started with that and we will see how much progress we can make in an hour. So our first question is 228 summary ranges. You are given a sorted unique integer array nums. A range A to B is the set of all the integers from A to B inclusive. Okay, return the smallest sorted list of ranges that cover all the numbers in the array exactly. That is, each element of the nums is covered by exactly one of the ranges, and there is no integer x such that x is in one of the ranges but not in nums. Okay, each range should be A to B if A is not equal to B and just A if they are both the same. So we get 1, 0, 1 and 2. This will become one range, and then 4 and 5 will become one range, and then 7 will become another range. So we have to, I guess this is somewhat similar. We will try to find what is the parent. So I guess we can again try the union and find approach here. We will see if there is a smaller number. So for each number in the set, so if we have all the values are unique, so for each number in the set, we will check if the number -1 exists in the set or not, because we have to just figure out the beginning and the end. So if we have 0, right, so if we start with 2, we know that 1 exists, and then for 1 we know that 0 exists. So we just start at 0 and then we keep moving till we find the maximum number that you can get in the set, and then just put that starting and the end value uh, in the output list. And if you find that there is no smaller value and you start with this element and there is no greater value, then you just put that element. And we can do this by union and set such that we have a list of all of the elements. But I guess that would be more useful if we have, like, if we want to know the length or if we want to keep track of all the elements. But in this case, I don't think we need that. So let's just try the first simpler solution. If there is no smaller number, then just start at that position and try to move up as much as possible, and then maintain two variables. That will be start, where we are starting, and end. Both will start at the same point. Same point. And then move end by +1 each time that we find end +1 in the set. And then we will have conditional logic. If start is not equal to end, we will just return start, and then we will add just start, and if else, we will add start arrow end. So let's implement this. Since we already have all the numbers as a set, but we still need to convert this into a set data structure, because that allows us to access the elements, like find the elements in O of one time. So we can do num set, then we get a set of numbers, and for each number in num set, we'll check if num -1 not in num set, then we will say that our start is num -1. Sorry, our start is num and our end is also num. And while num, end +1 in num set, move end to +1. And at the end, we will have, if we start at 0, 0 will move to 1, 1 will move to 2, and then we will have 0 and 2 at start at end. So if start is equals to end, so in the case of 7, this will never be satisfied. So we will have the initial values only. Then in the result, or we can maintain, yeah, we can just maintain a result, a list, and then we can say result dot append. Do these need to be sorted? If they need to be sorted, then we will just sort the result later. Let's see. Nums is sorted in ascending order. Okay, so this is great. Now that we know that nums is sorted in ascending order, we can simplify it even more. But let's try to go ahead with this for now. We will just append the string version of start. Else, we will append result dot append string version of start plus an arrow plus the string version of end. And then let's try returning the result. We worked on the test cases. Let's try submitting it. Okay, so this needs to be sorted. And for that, we don't need to do much because our nums is already sorted. So we can update this as we will go for each number in the nums and then we will mark that as start. I think we should enumerate because for, or we can do I is equals to 0 while I less than the length of nums. Start is equals to I and is equals to I as well. While so we will move the end pointer while nums end plus 1 is equals to a nums end. Then just move end pointer to 1. So we start at 0. We know that, okay, so we also have to make sure that the pointer is not going out of index. So while end so while n plus 1 is less than the length of numbers and this condition is satisfied, we will move end to a plus 1 position to start at 0. We say is the first position 1 larger than the 0th position? That's true. Then we move end to end is equals to this position. And we continue till we reach here. We see that 4 is not equals to 2 plus 1. So now we have if start is equals to end, then you just append result dot append. And this time we have to take the string value of nums at the start. Else we have to take both the result append string value of nums at start and we need the string value of nums at end, and then we need to update I is equals to end plus 1. Let's try running this. It should be +1. It works on the test cases. Let's try submitting it. Got it. So we are just iterating over everything once, and we are seeing as soon as moving to the next, considering the next number to be the part of the current set makes sense. Just add it. Else, just move to the next thing. We can simplify this part a little bit. We can get the current string and then append it, but it makes sense. I think it is a correct solution. So let's try to see what other people have done to approach the same solution. Let's see a more Pythonic way, maybe. So we have ranges, and then for num in nums, if not ranges or n is okay, so they are using tuples. They are not directly storing these. Just collect the ranges, then format and return them. So ranges will be if not ranges or, so if it's not ranges, then just add an empty range. And then for the last one, for the last element of ranges, for the first element, just say it's the number. Uh, let's try running this once. Let's see what it returns. So we have our code, working code, and then we'll say we have the ranges and we are collecting the ranges. Then for each number in nums, we are saying that if there is nothing in ranges or if the current number is greater than the range that we have at the last position in the list and the last element in that +1, then we say ranges is append a new list in that. And then for ranges, the last thing that we just appended. So if it is just +1, then we will go 1 this. So this will do all of our elements after 1. So basically we will preserve. Let's see what this does. And then we will print ranges. And then let's just return ranges for now. Yeah, exactly. That's what I'm thinking. Like, why, what is happening here? Is it part of the same code? Is this supposed to be this? No, I don't know what's going on here. Let's not dwell on these Pythonic solutions much. We know what the correct solution is and how to approach it like in an explainable manner. And let's just stick with that for now. Submit it once again. And then we can move on to the next question, which is merge intervals. Given an array of intervals where interval I start and end, merge all the overlapping intervals. Return an array of the non-overlapping intervals that cover all the intervals in that input. So we start from 1 to 3 and then we have 2 to 6. We'll go if, so the brute force way would be to say keep iterating till you have no more overlapping things. But that's very costly. So let's figure out a way how to keep track of what's the start, what's the end that we have already seen. And then start and end can go to 10 to the power 4. One way would be to create an array. So like if these are sorted, then we can make better use of them, but they don't seem sorted in that case. Can we just iterate over them and see like 1 and 3 we have, and then we encounter 2 and 6. If they have a common element or they overlap, we merge them. Then we come to this. Do we forget about this? Do we abandon this? Or I think here we might have to find like what is the biggest element just above this and what is the smallest element just below this. Because I know we have to implement a way to check like if we have any two arrays, which is start 1, comma, end 1, and we have another array that is start 2, end 2, then we have to check if uh, start 1 falls between this range, right? Or if end 1 falls between this range, and then we can merge them with like the smaller element. Or I don't wanna, let's try see this. Okay, sorting is an option. You sort these 1 to 3, 2 to 6, 8 to 10. And now that we have sorted a list, then we can just abandon. Then if we see a larger element, you can just forget about the previous ones. So if to Yeah, so you have to sort them. Basically, there is no other way. Like, you can't just directly iterate over them, assuming they are sorted. So if they are sorted, you just go one by one after one another. You sort them by the small their start, because that's what we are looking for. And then you keep track of the previous one. You start with the first one, and if the interval start is less than like the previous end, we say previous end is equals to either the max of the previous end or the current end, because we can have some cases where this is even larger than end 2. So this will be engulfed by this whole thing. Maybe the start. So we can have example like 1 to 100, and then we can have 2 to 15, 2 to 14, and then we need to make sure that our end is updated to the maximum of these two numbers. And since we already know that the beginning is sorted, so that will remain the same. If it is not, like these are not overlapping, so next number we see, so after we have merged these, we still get 1 comma 100, and then we get 200 comma x anything. We append the merged one, so we can just forget about this, we are done with this. And the previous one now becomes this, and then we move forward, and at the end we append whatever is remaining at the end, and we return the merged solution. Yeah, so sorting is the important thing. That was like my first question. If this is sorted, that makes things easier. Otherwise, we have to do some tricks, random things to find the number that's just below it, the number that's just above it. So this works well. And if we can see intervals, another thing I wanted to check is the sort uh, key sorts it in. So the sort function sorts it in place, and we have to use the key lambda, and then we are sorting based on the starting position. And is there a better way to do this? I say it's best that, is it given that we always have one interval? Yeah, it is given that we always have one interval, so that makes things a little bit easier. So we can say this is our results. And then we have to sort the intervals in place. So we just use sort, and then lambda of x, we are sorting based on the 0th element, the start positions. So we will have the minimum position already at the beginning, and then we take the previous, the one we are comparing with, that to be interval, a 0th index, and then we take the interval in intervals. Then we compare if our previous intervals end is greater than our current start, then we have to merge them. If our previous interval's end is larger than current interval, will it also work with equal? Because here we have 1, 4, 4, 5, and we are merging them. So we have to go this. If it is greater than or equal to the current interval start, then we have to merge them. And the way we are supposed to merge them is we have to make sure that previous is basically the current. So I guess I would call it the current set, the current interval. And in the current interval, we have to make sure that we get the max of current interval and the interval that we are just looking at. So basically another current interval. And then this will be merged. Else, if this is not true, if they don't overlap, we don't have to change the one because this will be already be minimum. We have sorted based on that. So our current intervals minimum will remain the same. And then else we have to make sure that we are abandoning or we are safely storing our current interval in the results. And then we are updating the current interval to the interval we are looking at. And at the end, we will have a case where we have not appended the current interval we are working at. So we have to append that as well. We can just copy this line and then just return results. Let's try running that. Okay, this is an error in lambda x. Okay, it needs to be that we are specifying key. It works on the test cases. And it works on the submitted solution. Let's try to see what other people have more commonly submitted. They are also sorting things. The result is already this, and then we take that and then we just keep changing this. So instead of maintaining a separate variable, they are just using this. And this also allows us to not be worried about this line. So since we are consistently updating the results itself, we don't have to worry about the results dot append current interval at the end. And we also don't have to worry about this. But we still have to start at 1. So most of the things remain the same. It's the same approach. So let's try and move on to the next one quickly. We are trying to cover more ground today as much as possible. So next question is insert interval. We are given an array of non-overlapping intervals where interval is start and end of ith interval, and the intervals is sorted in ascending order by start like we did in the previous turn. We are also given an interval, new interval, start and end, that represents the start and end of another interval. This is the new interval we are inserting. Insert the new interval into interval such that intervals is still sorted in ascending order by start and intervals still does not have any overlapping intervals. Merge any intervals that overlap with this and return intervals after insertion. Note that you don't need to modify intervals in place. You can make a new array and return it. That's okay. So we say that this is 2. So basically we have to see if this is overlapping. So at this time we have to check if this overlaps with any of these, because if it was 1, so let's take the condition 1 3 and 6 9, and our new interval was suppose 2 to 7, then we will have to give the result 1 to 9 as the final result. So we have to check that on our start and end both though they don't overlap. So basically we check for each, we'll iterate for each of the intervals. For interval in intervals, we will check, and to make things easier we will also maintain a result separate list. And then for each of these, if there is no overlap, add it to the result, right? And if there is overlap, then uh, keep the current, basically merge the current interval and the new interval and assume the whole thing to be the new interval. Right. So first we will go 1 and 3. Do you have any overlap with 2 and 7? We do have, so we will combine these as 1 to 7, and then we'll compare, does 1 to 7 have any overlap with 6 to 9? And since it does, we'll combine it to 1 to 9. And since we don't have any previous overlaps, I guess once we find that there is no overlap, we will insert this and then just break the loop and then continue inserting all of the rest of the elements normally, because we don't need to check. Once we finish, we say that there is no overlap. We can just insert this. But at what point do we insert it? So we start with 1 and 2. There is no overlap. You insert it. Then we go to 3 and 5. There is an overlap. So we make the new interval to be 3 to 8. Then 6 to 7 has an overlap. Then the interval becomes 3 to 8. And then 8 to 10 also has overlap. So that becomes 3 to 10. And then this does not have any overlap. So we insert this and insert this. So we also have to check if our start is bigger than the end of the current thing we are tracking, the new interval. We have to insert the new interval and break. Right. So our breaking point would be if the start of the new interval, if start of the interval is bigger than the end of the new interval, then break and insert the new interval. Sorry, insert the new interval and then break. And the result and then break, right? So let's try doing this. We'll obviously face some issues. Let's solve them along the way. So we'll have our results. We have our new interval for interval in intervals. We'll say if no overlap. So if our interval start does not fall in between. So we need a check, a good check with like minimum operations that can check overlap. So let's try creating that. If the start of the interval is not between this, right? So new interval, if it is not, between this range. And it's not, like the end is also not in between range, then we can say that this is clear. Because, okay, another way would be if this is too big, then we have to combine that. So if it is 1 to 100, and then our new interval is just 2 to 4, we also have to consider that possibility. So in any way, we have to check like this does not overlap at all. So we have to make sure this does not fall between this, and this does not fall between this, and this does not fall between this, and this does not fall between this. So currently I'm seeing 4 checks, and maybe there's a way to simplify it. Let's try writing them first. So it will be uh first will be interval 0, and then new interval 0. So we are checking the new interval 0 is not in between this range anyhow. And then third, we are checking that the new interval I guess another way would be to get the max of things and then do it that way. Right, so this is a bad approach, I can see already. What we can do is we can get the minimum of 1 and 2, that will be 1, and then the maximum of both, which is 100, and then we can see that this does not fall into that. So we can take maximum of these, which will be 4, and minimum of these, which will be 2. So we can have 2 and 4. Let's keep this check for now. I know this is bad, but we'll improve this later. So if not first, so if first or second or third or fourth, if any of these are true, then the intervals overlap and we have to merge them, else just add the current interval into the results. And then we also have to check that if our new interval end is smaller than the start of interval, then we just append new interval and break, right? Or we can just break doesn't matter. And then now we have to use I guess, because right, so we get to 1, 3, and this is not true because we have 2, which is bigger than 1. So we perform all these checks, then we say the intervals overlap. So we will update the new interval 0 and the new interval 1 to be the 0 will be the minimum of the interval and the new interval, and then this will be the maximum of both end places, right? And else we just do results dot append, and then append interval, and we also have to set new interval to empty such that we can perform a check that if it is not empty, right? Ideally we are supposed to not receive empty. Yeah. So if it is not already empty, then we have to append it. So I guess this code can be saved if we just break here, because if we break here, then we always have to result dot append this, and then we get this, and then we can just return result. So this is the major part that I'm worried about, that this is too much and we need to simplify this, that there must be an easier way to compare the overlap, but let's try running this once. Emily. Okay, we have not updated this. Awesome, thank you. And let's try submitting it once. This works. And now we need to optimize this. Currently, we are checking that either of these numbers overlap with the other or not. Maybe what we can do is see if the start is bigger than the end, right? If the start is bigger than the end, or the end is smaller than the start, there is no way to overlap, right? So if we start with this, if the end, sorry, what did I say? If the start is bigger than this number, there is no point. If this is smaller than this number, there is no point, right? So we can check if our new intervals start is bigger than the end of the current interval, or the end of our current interval is smaller than the start of the current interval, this is a no overlap situation, right? No overlap. Else, there is overlap. Let me make sure that the opposite is true. That if the start is actually smaller, so let's make it 2, but let's go even further. Let's make it -10. And the end is greater than this, let's say 400, then yeah, this is an overlap. So this is a no overlap situation, and this is a overlap situation. Right, so instead of these 4 checks, we are done with just simple 2. That if they are different, then there is no overlap. And if there is no overlap, we can just say result dot append the current interval. And if there is an overlap, we can just do this. All right. And let's try running this. It works on the test cases. Let's try submitting it once. It works on the submissions as well. So this is one way to simplify our overlap check. And let's see if we can improve on this or some other places as well. So one thing that I can think of is we can just place the we cannot start with anything in the results array because we need to make sure that if there is nothing smaller than the new interval, we can still add it to the results in the first position. So we have to start with an empty thing, and then the next thing is bigger, just break, add it, and then just keep moving. I guess this makes the most sense right now. We will also see what other people have submitted. Yeah. This, I guess, is someone else's solution. They have a empty results. They have I and N, which is the start and end. They also have the start and end of this. While I is less than end, and the intervals I start and less than our start, we'll just keep appending them, and then we'll do the same at the end. And then we will just keep updating the start and end positions while we are still in range and the starting position is smaller than end. Makes sense? And then we will append those and then we'll return. Let's try doing that once. So we have our result and we will return our result. Right. We have our uh, initial position and then we have our length of nums, the last position we can go to. We have our current start and end positions of the new interval. And then first, we will add all of the so this works basically because we are only performing one check. If your end is smaller than this, then there is no way to overlap, right? So if 2 is smaller than 4, there is no way you can overlap. First, we will add all of the intervals that end before the new interval even starts, right? So we will keep going as far along the array as we can while we have the intervals at that position at their end is less than the start of the new interval, and we will just go +1, and before this we will append it to the result, append intervals I. Right, so this inserts all of our intervals that end before this even starts. And then we will see that we will keep going. Now this is to insert in create the create the new interval by combining all of the overlapping intervals. So basically, now that there is some overlap, now we have to keep going. So this overlaps, right? So now you don't no longer have 4 bigger than 5. So these overlap. Now we have to keep going till the end condition is met, which is your start becomes bigger than the end. So this will keep going till the intervals at that positions start, right? The start is smaller than or equal to the end. So even if you're equal to the end, so this is 8, you're still equal. This will also get merged. And one thing we have to update is I, obviously. And then we also have to update the start and the end positions because we are combining the intervals. So this will become the minimum between the start and the interval we are considering start. And the end will become the maximum of the current end and the end of the interval that we are considering. After this, we have all of the So we will finally insert all of the intervals that start after the end of the new interval, right? So we will again keep going as long as we need to, and we will just, in this case, we don't need to check. We have already appended this, so we have to append it. So result dot append. This will be again start comma end. In this case, we'll also have to keep updating I, and we will keep pending interval at this position, right? And at the end, we are returning the result. So this should ideally have all of the previous ones, the current ones that we combine. Nums is not, okay, it's supposed to be intervals, right? So all of the previous ones, the ones that we combine, and all of the ones at the end that don't come into play after in the overlapping thing, right? So let's try submitting this. It works correctly and it also achieves a good runtime. So that's the 1 hour mark for today. Today we were able to solve 3 questions in the intervals list, 228 summary ranges, which was an easy question. 56 merge intervals, which was a medium question. I had to look up the solution for that. And then the insert intervals, which is another medium question. I solved the first iteration. I implemented the first approach by myself. And then we looked at the other solutions that other people have implemented. And then we implemented the second approach. So that concludes the things for today. Hope you guys enjoyed. If you're watching the rerun, thank you very much. Thank you very much for joining.